Hey there, it's Jason from Codemanship with an extended video diary entry today. I thought it's been a while, so I owe you a little bit of refactoring or something practical like that. So today I'm going to be doing a refactoring. Its general name is Replace Conditional with Polymorphism, but the specific version I'm going to be doing is called Replace Type Code with Strategy. So I'm going to be working on this code here that calculates prices for fitted carpets. And it has to calculate the area of the carpet, the area of the room that the carpet needs to be fitted in for different shapes of room: rectangles, circles, equilateral triangles, and trapezium. So we've got a nasty switch statement, and as we know, switch statements have a tendency to grow. Every time we want to add a new shape of room, we'll have to change this code. And also we've got a whole bunch of parameters here for different shapes of room, different dimensions of room. So chances are the signature of this method will keep breaking as well. So from a maintainability point of view, by no means ideal. And we're going to refactor this into something much more modular and object-oriented and much easier to extend without having to edit lots and lots of code. Okay, so what I'm going to be doing is I'm going to be introducing objects for calculating the area of rectangular rooms and circular rooms and so on and so forth. And a good place to start with this might be to introduce a data object, a data class, if you like, for a particular shape of room. Let's start with a rectangle, which has a length and a width. So I'm going to use a refactoring here. In Rider, it's called transform parameters. You may know this refactoring as introduce parameter object. I'm going to introduce a parameter object that has a length and a width as fields. And that will be the first step to introducing this new class. And this is a rectangle. Okay. So that's kind of step one. And we've got this rectangle class, but its internal workings are exposed. We'd like it to calculate its own area. So the idea is we'll have different ways of calculating areas of rooms, but we want that to all look the same from the outside. So we want them to all have the same method for calculating the area. So first of all, of course, I immediately rerun. Oh, where are my tests? There we are. Let's rerun my tests. Make sure that everything is working the way it should be. This might take a while. Off we go. Awkward silence. There we go. That's good. Okay, now we're going to introduce a method. This will have to be a static method that calculates the area of the room. So we get that on its own. Let's rerun our tests. Talk amongst yourselves while it's doing that. And then what we're going to do is, so we've got this static method, we want to move this to the rectangle object. So we can do that by making it non-static. And then it needs to find an object to attach it to, since it's now an instance method. Okay, it needs an instance. Okay, let's rerun our tests. And yeah, it will have created up here. So let's put it in its own file. It's nice and easy to do. And retest. And you can see already that it's picking up that these, because the work's now being done internally, the data is only being referenced internally inside rectangle. We don't need to expose these. So let's make these private and retest. Now, our ultimate goal is to have a rectangle and a circle and an equilateral triangle and a trapezium that all essentially look the same from the outside, which is another way of saying they all need to implement the same interface so that we can handle this problem polymorphically, to use a big word. So let's extract an interface, and I'm going to name it after the enum that we've been using, that we're going to try and replace. Roomspag. room shape. Okay, and that's going to have an area. Okay, let's put it in its own file. So we now have this room shape interface that as we extract other kinds of room that do their own area calculations, they'll all implement this interface. Okay, so we now have in our fitted carpet this rectangle being passed in. I'm going to ask it to use the base class. So use the base type where possible. Okay, that's room shape. So if we go back into fitted carpet, you'll see now it's not passing in a rectangle, it's passing in a room shape. And as we extract more objects to do calculations in different ways, we can use that parameter to pass them in. So let's just rename this to room shape. Okay. So as you can see, they're kind of side by side at the moment, and that's a good thing, because my ultimate goal is to replace this enum with this type, essentially, with this strategy. Okay, and we're going to do a similar kind of thing for other shapes of room. So let's again introduce a parameter object that has a radius. So is there a way to deselect all of these? I wish there was. So it's just the radius we're interested for this one, for a circle. And let's call that circle. Rerun our tests. And scroll up there, we'll see that really belongs in its own file. Let's do that now while I remember. Okay, and if we go back to our fitted carpet, it's kind of rinse and repeat, really. This work here should really be done by the circle, not by the fitted carpet. So let's put it in its own method. Give it the same name as before, area. You would be so kind, thank you very much. Laptop's a little sluggish today. And again, we want to move this static method to become an instance method of circle. So let's make it non-static, move it to circle. And now circle is doing the work, which means circle's data does not need to be exposed. Getting a little ahead of myself there. I thought it had run the tests, but it was still thinking about it. Okay, so far so good. Now, what we want to be able to do is not pass the circle in as its own parameter, not to have a parameter called circle, to actually pass it in as another room shape, another example of room shape. So let's make this implement the room shape interface. Okay, and now when we go back to fitted carpet, what we're going to do, we're going to have to do this manually, I'm afraid, so it's a little hairy, is in our test, currently where we're passing in the circle here, in our second test, you can see that circle, we're actually going to pass that, because it implements the room shape interface, I can actually pass it in here instead. Okay, now that will only work if I then change it here to use the room shape. Now we're safe because we're asking, with using the enum, what kind of shape of room is the one we're supposed to be using. So we should be able to get away with that. So far, so good. And again, we're going to sort of repeat this process, but first of all, let's, we're no longer using the actual circle that's being passed in. So let's change the signature of this and remove circle, because we're not actually using it, hopefully. There we go. So we're gradually picking off all these different parameters. Okay, and again, we're going to do the same thing with our equilateral triangle, which just has a side, the length of its side. So we're going to introduce a parameter object. We just need to know the length of its side, since they're all the same length, hence equilateral. And this is I'll be typing this more slowly. Equilateral triangle. Okay. Safety first. Let's rerun the tests. And again, what we're saying is the work using the equilateral triangle's data shouldn't be done here. It should be done inside the equilateral triangle. So let's introduce a method that calculates the area of the equilateral triangle. And then what we're going to do is we're going to move that static method, make it become an instance method of equilateral triangle. And that will allow us to hide its data. Okay. And so this will now be up here at the top. Let's once it's finished running the test, let's put it in its own file. Okay, we don't need that private set, so I'll just fix that while I'm here. And let's fix that while we're here as well. Doesn't need to be exposed. Okay, and we're back to fitted carpet. So again, we're passing in the equilateral triangle here, but really we want to pass it in as a room shape, as that second parameter. So let's go back to our tests. And where's our equilateral triangle is. So this is the one where we actually use it. And all the others, it's just, and we'll pass that in as the room shape. Because, it doesn't have the same interface, Jason. You need to fix that. Got ahead of myself there. Okay. So now we're passing in as the first parameter. And what we need to do in fitted carpet is use the room shape. So So we're exploiting polymorphism here. It's always the same parameter. Okay, we're good to go. So finally, you can see here that we've got one last one to do, the trapezium. So let's introduce a data class that has the fields of a trapezium. Oh no, actually while we're here, let's remove equilateral triangle from our method signature since we're no longer using it. Okay, good. And so finally, let's rinse and repeat. Let's do it again for the trapezium, which has two base lengths, A and B, and a height. So transform the parameters, which is just the last three there. Should be, okay. And we're going to call this a trapezium. So far, so good. Now let's extract a method that calculates the area of the trapezium. Again, the same name as all the others. And then finally, let's move this to where it really wants to be, which is on the trapezium itself. And again, in the test, we really want to pass it in polymorphically. We want to pass it in as that second parameter. So there's the trapezium that we actually use in our trapezium area, in our trapezium test. Let's copy that and pass it in as the second parameter, as the room shape. Oops, didn't like that. What did I do wrong there? Aha, yes. Too many parentheses. Need to be careful. And again, it's telling me trapezium does not implement the interface that it needs. So let's make it a room shape. I should have done that first, really. And back to our test. That should now be fine. So let's rerun our tests. And again, back to fitted carpet. That means that we no longer need. Oh, let's just move this into its own file while we're about it, so it's easy to see in the Project Explorer. And again, now that we've moved this method, we've got some stuff we can hide. And we can make it immutable as well while we're in here. So let's make it get only. Okay, let's rerun our tests. And in our fitted carpet, we no longer need that trapezium parameter, so let's get rid of it. Oops, then trapezium does not exist in the current. Ah, yes. Oops-a-daisy. I'm supposed to use room shape. Yeah. Polymorphism. Let's try again. This is why we take small steps. Okay, so now we're passing in the room shape. And in reality, we just need the area of whatever the shape of that room is. So we don't need the switch statement. We just need to ask the room shape to give us the area. It's as simple as that. And that should do the job. So the switch statement is gone. In fact, we can probably clean up a little here. We don't really need a local variable. Since it's room shape.area kind of makes sense. So let's inline that. And that makes it even simpler still. And now you can see that this the shape parameter here is not being used. So we should be able to do a safe delete on that. Let's just rerun our tests. And if you take a look inside our tests, and find them, there we are. So you can see now that any references to the shape enum have gone, which means we should be able to do a safe delete on this. Okay, it's done it. So it's gone. So we've replaced that enum, that type code, with the strategy pattern, different strategies for calculating the area of carpets for different shapes of room. Which means if we want to add new shapes of room, we can do that by extending the software rather than rewriting the existing code. and that makes our software more maintainable. Now, often when I post these videos and we do these refactorings, people will say, but now there's lots of objects. So to them, it will seem that I've made it more complicated. But the complexity is here and not here. This is a lot simpler. This is simple. This is simple. This is simple. This is simple. So the complexity is in the number of parts as opposed to how complicated those parts are. And this is kind of the price that you pay if you modularize your software. And if you modularize it too much, then you're going to get a lot of parts. But each of the parts is only doing what the parts were doing to begin with. I've just realized I haven't fixed that one either. So let's finish that off for sure. Okay. So this is an ongoing conversation, particularly with less experienced developers who see nothing wrong with the static functions and the switch statements and all, and the long parameter lists, because they think that simple means all the code is in one place. Whereas more experienced developers tend to lean more towards breaking things up so that when you make changes, you're only having to change one file. It can certainly help also with version control and with merge conflicts. If you don't have lots of big files, because what I've seen is quite horrendous code with these kind of switch statements in them, for example, is that, you've got dozens of parameters and so many different cases, and they just grow and grow and grow and go from tens of lines of code to hundreds of lines of code or even thousands of lines of code. So I tend to lean far more towards modularity. And I've used the names of the classes and the interfaces and the method to essentially explain what's going on without the need for the switch statement. So there you go. That's the refactoring replace conditional with polymorphism. I'm going to post a link to a GitHub repository with a copy of the before code, the code I had when I started. So you can have a crack at that if you wish, if you're a C# developer. So I'm hoping to get some more video diaries, kind of some more practical kind of stuff like this in the near future. So if you're enjoying these or finding them useful, ring the bell for notifications and subscribe to be kept up to date. So anyway, stay safe and we'll speak again soon.